So this lesson continues our work in Unit 11-12, and what we're going to work on is some stuff that that pertains to some questions in boxes B and C of Unit 12. Specifically, we're going to look at descriptions of situations, tables of values, equations, and graphs. And what we want to do at the end of this, or what we want to be able to do at the end of this lesson, is we want to be able to represent a linear relation as a description in words, as a set of numbers in a table of values, as an equation of the form y equals mx plus b, and as the graph of a straight line. So what we're going to do this is we're going to work on one of the sort of a longer question that is straight out of your learning guide. This is straight out of 12b in your learning guide. So you want to have your learning guide open to those pages 12b and keep track of this as we go along here. So let's just take a look at the first page here. And this is what we're told. So here's the situation. Jared wants to rent a canoe for a day trip. He gathers this information from two places and decides to make a table of values and a graph of each of these relationships. Here are the two places he looks at. Big Pine Outfitters, which charges a base fee of $40 and $10 per hour of use, and Hemlock Bluff Adventure Store, which does not charge a base fee, but instead just charges $30 per hour to use the canoe. So what does Jared do here? He makes himself a table where he chooses different values of time, 0, 1, 2, 3 hours, and he calculates how much it's going to cost if he rents from Big Pine, so he gets 40, 50, 60, and 70, and how much it's going to cost if he rents from Hemlock Bluff, 0, 30, 60, and 90. And then he makes a little graph of how the cost changes with time for each of these two situations. So he just takes these numbers from his table and he graphs it. And you've had a lot of practice taking numbers from tables of values, and you've graphing both of them. And then we have a series of questions based on the information from his worksheet here. So what is the cost of renting a canoe, or each canoe from each of these two places, if Jared decides he's going to cancel his reservation? So we want the cost for BP, which is Big Pine, and we'll refer to Hemlock Bluff as HB. So if he cancels his reservation, he decides he's not going to rent it, or he rents it for 0 hours. So we'll say T equals 0. How much does it cost for Big Pine if he rents it for 0 hours? Great. Not quite. Take a look at that table there. Yeah, it's $40. He's still got to pay that $40 reservation fee that Big Pine charges, or that base fee. What about for Hemlock Bluff? 0 hours corresponds to how many dollars here, Riley? 0. Okay. Now they ask us here to compare the rate of change of cost for Big Pine and for Hemlock Bluff. Now, if we want to do a rate of change is the same as slope. So let's say we want to calculate the slope for the line for each of these two graphs. So what we should probably do is we can look at our graph, and we can take 2 points on our graph and draw a little triangle, that little right angle triangle underneath it. And then we can calculate the rise and the run. So we'll do this for Big Pine first. Okay. What is our rise for Big Pine if I'm going between, these 2 points that I've drawn the triangle in between here? How much is this going up by between these 2 points? Okay. Logan, how much is this going up by from here to here? What's our rise? Well, it ends at 60, and where does it start? Not quite at 20. Oh my God. Where is it starting here? Oh. Yeah, 40. So what's our rise? What's the change in between those two?
20.
How much? 20. Yeah, it's going up by 20. And then our run is how much this is going over by. So we look at where it starts here and where it ends over here. So where does it start and where does it end here, Logan? Well, we're starting here, and we're going to here. So what numbers is it going in between? Okay, not 1, but it ends at 2. Yeah, so 0 and 2. So how much is the run? How much is that changing by? If we go from 0 to 2? Exactly. So then we go down here to calculate our slope. Our slope is going to be rise over run. So 20 over 2 is going to be 10. So our rate of change is $10 per hour. Now we want to do the same thing for Hemlock Bluff over here. Okay. Let's take 2 points again. Take here and here, and we'll draw our little triangle, and we'll figure out our rise and our run. Okay. So between those 2 points that we've done right there, what's our rise going to be there, Drake? Exactly, 60, because we start at 0, we go up to 60. And what's our run going to be between those two, Drake? 2, yeah, because we start at 0 and we go to 2. So when we calculate our slope, we do rise over run is going to give us 30, or $30 per hour. Okay. Now, we could have done this without actually calculating the slope, because if we go back up to this description that we had at the very top, what did they tell us? Big Pine, $10 per hour of use. Hemlock Bluff, $30 per hour. Okay? So often in these kinds of questions, the rate of change or the slope is given to you in the question as a rate of change, as something per something else. And that's what this question here is asking us. What is the relationship between the rate of change of cost and the cost per hour? Well, the rate of change of cost that we got from the graph and the cost per hour that we got from the, let's say it's from the description, are the same. Okay? They are the same. Okay. Now let's take a look at the next page. Okay. Here we're asked, which graph illustrates a proportional relation? How do you know? Well, what is a proportional relationship? When we worked with proportions earlier in the course, we said that a proportional relationship was something where if one thing doubles, the other thing doubles. If one thing triples, the other thing triples. Okay? So what we're looking for is the one where if, let's say, time doubles, the cost doubles. Okay? So let's look back at our two tables. Okay? And let's look for one where if we double the cost, or if we double the time, the cost will double. So we're doubling the time if we go from 1 to 2. Okay? There it's doubled. For Big Pine, is the cost doubling as well? What do you think, Riley? Does the cost double going from here to here for Big Pine? Is 60 twice as big as 50? No, it doesn't. But what if we look for Hemlock Bluff? Hemlock Bluff, we go from 30 to 60. So this one over here, it is doubling. Okay. So Hemlock Bluff here is the one that represents a proportional relationship. So if time doubles, cost doubles for Hemlock Bluff. Okay? So Hemlock Bluff illustrates a proportional relationship. How do we know? We know because when the time doubles, the cost doubles. And this is called direct variation. Now, how can you recognize direct variation from a graph? Take a look at our graphs back here. Let's look at Hemlock Bluff's graph. Where does it start? What is the first point on this graph? Okay? Drake, where does this one start? At 0, 0. Yeah. Anytime a graph goes through 0, 0, it's going to be direct variation or a proportional relationship. So we can say that the graph starts at 0, 0. If a graph starts at 0, 0, we have direct variation. And this brings us to question 3 here. Which graph has an initial value other than 0? Well, if we look back at our two graphs here, we've already said Hemlock Bluff starts at 0, 0, right here. The other one starts at not 0, 0, but 0, 40. Okay. So which graph has an initial value other than 0? We can say Big Pine starts at 0, 40. If it starts at 0, 40, this is called partial variation. So if it starts at anything other than 0, 0, it's not direct variation, it's partial variation. Okay? And we had already established that this wasn't proportional. Okay? So let's take a look at question 4 here. Which outfitter company should Jared choose if he estimates he will canoe for a half hour, 1.5 hours, 2.5 hours, etc., etc.? So we can just fill in this table here, working out our costs here. Now, how can we figure out the cost for half an hour? What do we think? What would you try doing if they asked you the cost for half an hour? Let's look at our table here. Where would a half hour be on our table? Would it come down here at the very end, after 3? It's going to come sort of halfway in here between 0 and 1. So if it's halfway between time of 0 and time of 1, we can just choose a number that's halfway in between the cost. So halfway between 40 and 50 would be a cost of 45. The next one is 1.5. It's going to be halfway in between 1 and 2, so that would be 55. And then 65. And we can do the same thing for Hemlock Bluff. Hemlock Bluff, sorry, I went the wrong way there. Hemlock Bluff, let's see, halfway between 0 and 30 would be 15. The next ones were 30 and 60, so halfway in between those would be 45. I think, let's see, oh, keep going the wrong way. Between 30 and 60 is going to be, right, 45. And then halfway between 60 and 90 would be 75. Okay. So what we did was we went, how did we determine our answers? We chose values halfway between the ones given in the table. Halfway between those given in the table. Okay, because we were halfway in between for our times, so we took numbers that were halfway in between for our costs as well. So now just looking at these costs, who should Jared choose to rent from if he wants a half hour's worth here? Which one should he choose? Corey. Why? Yes. Okay. What if he wants to rent for 1.5 hours? Which one should he choose? Okay, because again, it's cheaper. And what if he wants to rent for 2.5 hours? So now this one is cheaper over here if he rents it for longer. So we chose values that are halfway between those given in the table, and then we looked for the lower price. Because we're assuming that Jared wants to pay as little as possible for our canoe, for his canoe. Okay. Well, next up, we want an equation to model the cost for each outfitter. Okay, we're going to use C to represent the cost in dollars and H to represent the time in hours. And they've given us the C over here already. So let's just take a look back at the descriptions that we have. Let's do Big Pine first. For Big Pine, we've got a base fee of $40 and $10 per hour of use. Okay. So back on this page, we've got H is going to be our time in hours here, so we're going to need an H over here. How is the rest of this equation going to look? Okay. $40 base fee and $10 per hour. Remember, our equations are always going to be something equals some number times our variable plus something else. Or it's probably easier to do the plus something first. So something plus some number times our other variable. So what's the number that's going to stay constant here, that we're going to have to pay no matter what for Big Pine? Yeah, which was how much? It was $40. Yeah, there's that $40 rental cost plus how much does he pay each hour? Right? How much does he pay each hour for this one? For Hemlock. Big Pine, sorry. $10 an hour. So it's $40 plus $10 times the number of hours. Well, what about for Hemlock? Hemlock is just $30 per hour with no base fee. So what's it going to be here? Well, we're not going to have the something added on the front. We're just going to have 30 times the number of hours. Okay. And, okay. So we got one more question here at the bottom of the page. So these are our two equations. Okay. All right. If Big Pine Outfitters decided to change its base fee to $50, so what was it before? It used to be $40. Okay. And still charge $10 per hour. What effect would this have on its graph? Okay. So let's look at what the graph looked like before. Let's say this is our graph, this is T, this is C, okay? And our graph before went kind of like this. It started right here at 40, and then our slope here was, our rate of change here was 10. Let's see. We won't put that on. That'll just be confusing. Okay. So it started at 40 and then it went up from there. What if instead they decide that they're going to charge $50 and still $10? So let's try that. So if we change that base fee from 40 to 50, that 40, that base fee represents where this graph starts. So instead of starting at time equals 0 at 40, it's going to start up a little bit higher at 50. But we're not changing the $10 per hour, so we're not changing the slope of this line. So we're going to have another line that goes up right beside the other one. These lines are parallel. It just starts a little bit higher up. Okay. Now, let's write an equation to model this new cost. Well, our old equation was C equals 40 plus 10H. What is our new equation going to be if we change that cost from 40 to 50? What do you think? Plus, has the 10H changed? Has the $10 per hour changed? So it's still going to be 10 times the number of hours. So now they ask us something similar for Hemlock Bluff. If Hemlock Bluff Adventures decided to change its hourly rate to $40 from $30, okay, what effect would this have on the graph? Okay, I got to give myself a little bit more space here. Okay, so let's keep in mind that our old graph for Hemlock Bluff looked like this. Okay, it started at 0, 0, because it was direct variation, and it went up kind of like this. Okay, if we're changing the hourly rate from 30 to 40, we're changing the hourly rate. Are we changing where the graph starts? What do we think? Right. Okay. We're not changing where it starts because we're not changing that base fee. Okay. What we are changing is the rate, or we're changing how much it goes up by with each hour. So, or we're changing the slope of the graph. So if we change our slope from 30 to 40, the slope is getting bigger. So what does that mean for our line if the slope gets bigger? What is our line going to look like? It's above it because it's going to be 40, which is bigger, which means the line is going to be more slanted up or steeper. Exactly. But it's still going to start at 0. So it's going to start down here at 0, and it's just going to go up more steeply. So we should label this. This is our $40 per hour, and the blue one here is our $30 per hour. Okay. Write an equation to model the new cost. Well, our new cost, I'll do this in red, cost equals something times h. What do we have to multiply the number of hours by to get the total cost now? Riley, what do we have to multiply it by? What do we have to multiply the number of hours by to get the cost? But we've changed that 32, so it's going to be, cost is 40 times the number of hours. All right. Okay. And now we're on to the last two questions here. Okay. This is where we put it all together. Okay. For Big Pine Outfitters, how are the pattern in the table of values, the description, the graph, and the equation related? So let's look at the description first. Big Pine Outfitters charges a base fee of $40. This $40 here is our fixed cost, okay, which doesn't change. And they give us $10 per hour, which is our rate. Okay? How do those relate to what we see in the graph? Well, in our graph, it starts at $40. Okay, this is our, we can call this the y-intercept. Okay, so a y-intercept on the graph is the same as the fixed cost. Or the fixed cost is the same as the y-intercept. What about this rate, this $10 per hour of use? Where do we see that on our graph? Well, when we calculated our slope, we found that our slope here was $10. So our slope was 10, so the rate is the same as the slope. Okay? So we could go straight from this graph, from this description to these things down here on the graph. Well, how does all of that relate to our equation? What does this 40 here represent in our equation? Well, the 40 is our fixed cost or our y-intercept. Okay, and I'll just draw an arrow over there. Fixed cost, right? What about the slope or the rate? Where does that appear in our equation? It appears in this thing that gets multiplied by the number of hours. So this is our rate or our slope. Okay. How does all of this fit together with what we see in the table? Well, if we look at this first line of our table, when time is 0, cost is 40. What does this 40 represent? What have we called 40? We've given it two different names. We've called it, what have we called it, Drake? 40 is our, or our, yeah. So if you've got a line in your table where your x is 0, that tells you your y-intercept or your fixed cost. Now, the other thing we can see from the table is, let's take a look at what happens when we change from one value to the next. This is going up by 1. Whoops. By 1. How much is our cost going up by from that line to that line? Okay, from the first line to the second line, how much does our cost go up by, Logan? From here to here. By 10. Where have we seen 10 before? What did we call 10? That was our per hour. It was our slope or our fixed or our rate. So our rate or slope. Okay? So all of these things, the fixed cost or the y-intercept and the rate or the slope, we can get them from a description, we can get them from a graph, we can get them from an equation, we can get them from a table of values. Okay? And they're all in there together. So the next page, the next question just asks you to do the same thing for Hemlock Bluff. So I'll leave that as an exercise for you to fill in. Take a look at what we did on this one and see if you can do the same sort of thing for the Hemlock Bluff description.